Hello everybody and welcome back to question number 21 on the 2003 Fermat paper. I've got my pen, I hope you've got yours. Let's take a look at this question and see if we can't come to a solution here. A sequence of numbers has 6 as its first term, and every term after the first is defined as follows. If the term is even, then the next term in the sequence is, so the term is t, the next term in the sequence is a half t. So we divide by 2 if it's even. If a term s is odd, then the next term is 3s plus 1. Thus, the first 4 terms in the sequence are 6, and then we divide by 2 to get 3. Then that's odd, so we do 3 times 3 plus 1 to get 10. Divide by 2 to get 5, because 10 is even. And then we're asked, what's the 100th term? Okay. We have choices of 1, 2, 3, 4, or 6. Okay. Now I can't immediately see any pattern going on here. So what I would suggest you do, if you're confronted with something like this, a sequence whose terms you are told, but is not something you've seen before. Like if it came to a geometric sequence or an arithmetic sequence, those are things I've seen before, and there's standard ways to write out the terms. Like the nth term can be expressed as AR to the n minus 1 if it's a geometric sequence. You can do things like that, but this is just a sequence that they've thrown at me. So what I'm going to do is I'm going to investigate a little more by writing out more terms. Maybe there's a pattern. Maybe it all terminates at 1, and for some reason 1, it's ones after a certain point. Or maybe it goes to a certain pattern or something like that. Okay, so what I'm going to do is I'm going to write out the next few terms, see what pops up, see if anything jumps out at me. So we had 6, and then it was even, so we divided by 2 to get 3. Then 3 times 3 plus 1 is 10. That's even, so we divide by 2 to get 5. 5 is odd, so we do 3 times 5, which is 15 plus 1, which is 16. Divide by 2 to get 8. Then 4, then 2, then 1. Then 1 times 3 is 3 plus 1 is 4. And then we get 2, and then 1. Then 4, then 2, then 1. Then 4, then 2, then 1. And it's just going to keep going on like this. So if I had to make a guess, I'd say it's one of 4, 2, or 1. And that narrows it down to 3 possibilities here. It's either A, B, or D. It's never going to be C. It's never going to be E, because it's not going to be 3 or 6 again. In fact, if I recall correctly, this sequence here is, I think it has a name. I'm not entirely sure. But what's coming to mind is the term Collat's conjecture. And I don't know if that's related to it in any way, but I think there's some conjecture that no matter what number you start with, eventually it goes down to 4, 2, 1, 4, 2, 1, or something like that. I don't know. But I think this sequence is actually a known sequence or a sequence of interest or something. But for our purposes, we've found the pattern just goes 4, 2, 1. So we just need to figure out which one of those happens to be the 100th term. Okay? So, let's get out a different color, maybe green. So that was our first term, second term, third, fourth, 5th, 6th, 7th, 8th, 9th. Then 10th, 11th, 12th. 13th, 14th, 15th. So it looks like every multiple of 3 from this point on is going to be a 1. And if there's 2 ways we can sort of tackle this. We can say that if we want term n, the nth term, if n divided by 3 has a remainder of 1, we'll get a 4. If it's got a remainder of 2, then we'll get a 2. And if it has a remainder of 0, which means it's a multiple of 3, we'll get a 1. So this is something called modular arithmetic, and that's certainly a way you can do it. And then 100 divided by 3 gives a remainder of 1, so the answer will be a 4. Another way you could do it is you could say, okay, what's the closest multiple of 3 to 100? 99, I would say. So the 99th term, that's a multiple of 3, so we know it's going to be a 1. 100th term comes after it. We know we go 3 times 1 plus 1 is 4. Then 2, 101. Then 102, we're back to 1. So we can do it this way and just pick a multiple of 3 that's really close. We can get 4 as well. And I think that was D, right? Let's just double check. Yeah, D, 4. So the 100th term in this sequence, this particular sequence, is 4. And that's what we bubble in. In the next video, we're going to take a look at question number 22, so be sure to give that a try before watching the next video.